Okay, I think everything should look fine. Yeah, let's begin. Welcome everyone for, let me see, yes, yeah, okay, let's begin. Welcome everyone to the course, Machine Learning. So my name is Da Yan. I think I should have the introduction video, slides here. You can also call me Daniel. So firstly, I would like to give a brief overview of the course. Before I move on, do you have any questions? If you have any questions, please feel free to mute and ask me anytime. So for machine learning, actually there are different ways of teaching the course. So one way is totally from mathematical side, right? So get the mathematical backgrounds of the models. And another way is totally hands-on. I don't care about what the model is. I just need to know what the model is doing, right? So whether it's clustering, whether it's classification, regression, which these terms we will see later in this talk, okay? And then I care about what's the input, what's the output, and then I use a model and run it, right, using Python libraries. So we will take the middle ground, okay? We will have to teach some of the mathematics there to lay the foundation for your machine learning background, right? So otherwise, you will just be a programmer using simple models, just knowing more models, right? So we want you to be able to understand deeper into the model and even inventing or changing some existing models and inventing new models. Okay, so this is why we also need some mathematical background. Okay, so you need to be familiarized yourself with probability theory if you don't already know. Let's say the Bayes formula. Okay, and you need to know how to take basic derivatives. Okay, so there are very complex derivatives for multivariate calculus, but that's what we will cover here, and you don't have to go over it yourself. But for simple derivatives, let's say if you take, let's say if you have log x, right? So you need to know what's the derivative of log x. Okay, right, so if you have a log x, take the derivative x, what would be the derivative? Right, so let me test it. So Latif, are you there? Yeah, you can unmute yourself. Just try to test the. Oh, I just realized that in Zoom we cannot use. It seems that it doesn't work well with me using Zoom's annotation. So anyway, so if you have log x, right, take a derivative x. What's the answer? Anyone can answer me.
1 over x.
Yeah, 1 over x. Good. Yeah. So these things are what you have to know. Otherwise, you need to go through the formula. Okay. So and the last one is the linear algebra. Okay. So we will need to know some linear algebra like matrix multiplication, those kinds of things. Right. So there will be some complicated ones like eigenvalue, eigendecomposition. Those things we'll cover later. Okay. We will go through these things with you. Assuming you have learned that, you will catch up much faster. And just one moment, let me clear the. I guess this log x is actually. Okay, so what we will introduce, we will also need to teach you some new mathematics, right? So these previous three are what you should already know. Okay, new mathematics is multivariate calculus. Okay, so in machine learning, you will find that what you are doing is actually have features. Let's say if you have let's say health record, right? So electronic health record, you have the patient, the age, like the other like health conditions and the blood pressure, etc. So you have a multivariate features. Okay, and then you want to use them to predict whether this person has this disease or not. You have a y. Okay, so you are taking y. If you think about it as a function, it's a multivariate function. Okay, y equal to f x, where x is a vector. Right. So in this case, we are not just taking derivative to one variable. We'll take derivative to more variables. Okay, and we will cover that in this course. Okay. How to do that. Okay. The next is linear algebra necessary for the course, just like the eigendecomposition. Right. So if you forget, we will recap. So don't worry on that. And finally, we need some statistics. Okay, so but whatever we will use, we will repeat, we will cover that. But if you already know that, you will immediately get it, right? Otherwise, maybe you need to review the materials offline yourself. Okay, let's continue. So the textbook we will be using is actually a little bit outdated, right? These days, people just watch videos, but I think this book is okay. I used this book when I learned machine learning. Okay, so this is the third edition, Introduction to Machine Learning. Okay, so the second edition is actually online. So if you click this link on the slide, it will bring you to the whole book. Okay, so someone shared it online. And so another even older book that is more comprehensive is the Bishop's book, right? So Pattern Recognition and Machine Learning. This is a real classical book by machine learning people, right? So, but it's very compact, right? So there are a lot of contents there. If you have time, you encourage you to read it. Otherwise, I think you can stick to our textbook. Okay? And even if you don't have the textbook, don't worry, you don't have to buy it, because everything we will be teaching will be covered in the slides and some lecture notes. So you don't have to buy the textbook. Okay? But there's a free version online for this old edition, which you can always use. And finally, Andrew Ng is a kind of star these days, right, in the area of deep learning, and he also has a machine learning course on Coursera. And if you are interested, you can take it, right? This is not a must. Okay, so I think his course is more intuitive, less math. Okay, so but we will teach a little bit more math than his course. Right, so the marking scheme, firstly, there will be 10% that is from your attendance, right? So we want to have some mechanism to push you to come to the classes. Okay, so, but it's not too much. Okay, if you miss some of the classes, it's maybe 1 point or half a point, that's fine. Okay, so we have more than 10 courses, right? So, and so you are allowed to inform leaves. By inform, if you look at the course syllabus, it means that you need to ask for leave before the class. Preferably way before the class, let's say in the morning, right? So, or even the day before, right? So, right before the class is kind of too rushed. Okay, so if you let me know that you want to ask for leave in the middle of the class, it will not be counted, right? It's explicitly mentioned in the course syllabus. There will be 10% attendance score. So what we will do here, just to let you know a little bit. So there's an attendance tool. If you have already taken my previous courses, you already know that. Right? So what we will do is we will take the attendance score from this app, and I will sample some students and call your name. Right? So we will have 2 big classes, so we cannot call everybody's name. Maybe I will randomly sample 10 people and call your name. If you're not here, then basically you will lose one okay, in the attendance. So I think if you are not here after a couple of samples, you are likely maybe 30% probability you will be wrong. Okay, so again, it's a trade-off because we don't want to spend most of the time just taking attendance. Right. So the second will be 2 written assignments we will give to you guys, because we will cover a little bit of mathematics, right? So we will have 2 written assignments on the derivation using the math tools, okay, on the models that we will be learning in this course, okay? And we are teaching machine learning. Okay, there are also courses teaching deep learning, etc. So we are not particularly focused on deep learning. Everything before deep learning. Okay, so deep learning, we will try to cover some of the deep learning, but that will not be the focus of this course. And another important thing that I have made a change since maybe last time I teach this course is to add some hands-on mini project and add some hands-on stuff there, right? So because nowadays, if you look at data science, I think it's kind of like trendy that you use Python libraries. Previously, people use like R. If you are using statistics, you're using R, right? So MATLAB is used by domain people like neuroscience people, right? So, but actually everything is moving to Python. Okay, so they are the same thing. If you look at MATLAB, it's a matrix-based software, right? So, and the Python has a NumPy, which is tensor, which can go beyond 2 dimensions. Okay, so actually everything is merging to Python. Okay. And so we will also have a final programming project. Okay, so we allow you to team up. Okay, and we don't have exams, you can see, right? So so this is also maybe more friendly to you guys for this kind of Zoom courses, right? So the virtual courses, because you don't have to sit in the classroom and you know so take paper-based exam. But we do require you to submit a final report, written report on the project due. We will have some recommended topics for you guys with some recommended data. But if you want to do some other topics, you can discuss with me first, and if I approve, then you can move ahead with your project. Okay. Otherwise, we will have some project for you to choose from, and we will have you know, allow teams. But if you cannot find any teammates, it's also okay if you do it alone. Okay. And if you are a PhD student or in your team, if there's any student that is a PhD student, right? The PhD student of the team should give a presentation about the project that you did. Okay. And this will happen during the allocated final exam period. Okay. Because we don't have final exam, the presentation will be for the final exam. And the grading scale. So I adjust the grading scale a little bit. Previously, if you take my courses, usually 85 or even 80 will be 8, right? So unfortunately, this time the department, as you can see from this email, right? So we are recommended to follow the update policy. So yeah, so this is not decided by me. Okay, so if you are up to 90, you're A. And some students actually get quite close to 90, 85 to 90, but unfortunately you will get B. Okay, so please work harder. Okay, I think this is basically what we have to follow. And on cheating and plagiarism. Okay, so by the way, for today, I will not take attendance because you know you are still in the ad-job period, and the students like choose a course later, maybe next Monday, they will not have the attendance. Okay, starting from next time, I will start to take attendance, right? And so on cheating and plagiarism, so there's a UAB academia honor code that you can check. Okay, so and in the department we are told to emphasize 3 strikes and you are out policy. Okay, so basically if we find you cheating, if it's a first violation, whatever you are doing, let's say cheating on the assignment, you will get 0 marks on the assignment. Cheating on exam, you will get 0 marks. Okay, and for the second violation, and you will fail this. You basically fail this course. Okay, and the third violation, the department will decide. Maybe the department will decide finally to report to the university, and some severe consequence may follow. Okay, and I think this is actually managed by Dr. Chen Cui Zhang. Okay, so she will keep bookkeeping how many violations you conducted. Okay, so in case that happens, right? So this does not just apply for one course. For example, if you cheat on a small assignment here and you get 0 mark for that assignment, that's okay, right? So it's maybe 10%, okay? But then you are caught in another course, right? So again, for the violation of another assignment, you will fail that course. Okay, so this is actually cumulative. Okay, pay attention to that. And yeah, so there are old tools, right? So older tools, what is before the Python NumPy library became popular, right? MATLAB is one important tool. Early on, you know, this is a big investment. The company, MathWorks, right? So they spend a lot of time developing it and porting all kinds of libraries. They have also the Tensor toolbox to to be compatible with Python's deep learning libraries, right? So because Python deep learning libraries are native in Python, not in MATLAB, right? So they have all kinds of things to accommodate beyond their matrix restrictions. Okay, and it's a commercial software, so they have maintenance and actively maintain. Okay, so some quality guarantee. Okay, so it's really matrix based. Every data item is a matrix. Okay, it's for numerical computing. So this is one tool. So there's also Octave, which is open source freeware of MATLAB. Right? So you can write MATLAB code, but you can run on Octave, which is free. Okay, so it's the most popular MATLAB clones, right? Open sourced. And you can also use R. R is a different language from MATLAB. Okay, Octave, MATLAB, they are all using the same MATLAB language. Okay, R is similar to MATLAB, but the language is a little bit different, the grammar. Okay, again, R, starting from the very beginning, it's a freeware. Right? It's competing with MATLAB instantly. Okay, so and it's most popular for statistics people. MATLAB is more for like neuroscience people. So if you bioinformatics, a lot of people are using R libraries. So like there's like a GC, so what is that name? Maybe GCNA. So it's the WGCNA library, right? So a lot of them are using our library. Yeah, but we will directly go into Python. Okay, I know a lot of machine learning people are still using MATLAB. Okay? Unfortunately, these days everything is moving to Python. Right. So I will give a lecture today about Python. And so that you understand the big picture of what's happening in the domain. Right? So previously, people doing numerical computing just using MATLAB or R. Now people move to Python. Just one moment, I see 3 chats. Okay, so yeah, so yeah, for some student question, I will refer to Gopi for answer. Right? So yeah, and
yeah, I will handle that.
Okay, thank you. Yeah, and so I will have a slide on Python shortly. Okay, so finally, give you just a very narrow view of machine learning. Right. So the very narrow view of machine learning is what we will stick to. Okay. Nowadays, it's totally different domain. Right. So what we are talking about is more like a relational table. Right. So we will have X1 attributes, right? We found marital status, tax income, and then say whether this guy will be cheating, whether we should loan, give money to that guy, right? So mortgage for them, right? So so this is kind of our classical set. You have a Y, and you have a bunch of features: X1, X2, X3. Okay, this will be what we are looking at in this course. Okay, and these days, actually, the trend has changed. People talk about deep learning, right? So you have natural languages of different lengths. You have images, which are raw pixels. You have streets, which are just signals and time series, like EEG, EOG, right? So these data, they will go to so-called feature extractor. Okay, like let's say recurrent neural network and convolution neural network. What they do is they finally extract the features into embedding or in a vector, which is like this. So deep learning has another feature extraction stage, but here we assume these features are well curated by humans. Okay, so we will skip the deep learning part, and we will definitely cover some of the deep learning because it's so close, but because we have another course totally on deep learning, right? So I want to downplay that part, right? And so here's the example, right? This model is more like an algorithm model. There are 2 different kind of models in machine learning. One is algorithm model. Okay, like a decision tree, right? So here what we do is, hey, which attribute splits the labels the best, right? Using which value, okay? And then we find that particular attributes and split the values, then we will go to the next decision, and which will use the second attribute to decide, right? So this is a dismissed algorithm for decision tree, okay? So we will not emphasize on decision tree because we have another course called data mining, right? We'll emphasize more on this kind of algorithms, right? So in machine learning, we look more on the gradient descent, those kind of continuous models, okay, the numerical optimization models. So we will treat this. Here it's like you go through the features and finally you reach an answer of Y, right? So here we will look at it more like Y equal to Fx. Okay, here is 3 features: X1, X2, X3. So it's a Fx vector. Okay, and then this is a continuous function in our case. Okay, we will not using this kind of discrete. This is actually, this is a parameter-free model, okay, where you don't have any necessary parameter. Here we usually have a parameter theta that we optimize. But you see that deep learning, gradient descent, they are all optimizing theta. And all we are doing is to estimate this parameter, model parameter, okay? Not for all the models, but for many of the models we will see in this class. Okay, so that's the end of the course overview. Any questions before I move on to the Python introduction? Yeah, if you don't have any questions, I will move on to the Python introductions. And just one moment. Let me see. Oh, unfortunately, I use the Zoom's. Let me see. I cannot find my mouse again. Okay, yeah, I have come to that. So I never get Zoom's annotation and the pen in work with the slides. So I will use the slides and make it. Okay, so that's the end of the course overview. And now to have a look at Python, and then we'll take a break and then we move on to the other. So okay, last chance. If you have any questions, it's time to ask me about the course.
Yeah, I do have a question.
Sure.
Are we going to get this slide from file and Zoom, or we just have to take note?
Oh, the slide is on Canvas. If you are on UAB, yeah. So otherwise, I think Dopey will handle that. Right? So,
okay, thank you.
I have a question.
Yeah.
Do we need to do all the projects using Python, or we can use MATLAB or other programming?
Oh, some of the projects are actually in Python. So we written most of the code for you. You are completing some of the code, right? And so this course, part of it is forcing you to use Python, because if you look at data science, it's really just now, because the Python libraries are so mature, right? So, but you can definitely do the counterparts in MATLAB. If we don't have specific requirement, you have to use Python, right? But for some of the assignments that's already written, let's say 90% of the code in Python, you have to complete the rest 10%. Then you have to use Python.
Okay, thank you.
You're welcome. Okay.
Professor, can you?
Yeah.
Sorry, can you please explain the final examination pattern? I think we lost the signal and I somehow lost the information.
Oh, okay. So the final exam is it says no. Actually, we don't have midterm and the final exam, paper-based exam. Okay. So we only have projects. We have 4 program projects, 2 written assignments, okay, and then final project. Final project you can team up, but no more than 4 people. Okay. So and you can also do that alone. 1, 2, 3, 4, all are okay. Right. So and then you have to write a report and submit your code. And do a demo. If you are a PhD student, you need to do a presentation. Okay.
Okay. Yeah.
Yeah, we will have recommended data and projects for you. So previously we leave it really open, and unfortunately the departments find that some students are using the course final projects for other course final projects. So that's why we have to make this change by following the department. Okay. And
so,
yeah.
So for the programming part, are we going to use the existing libraries in the Python or MATLAB, I mean R, or do we have to build up the whole algorithm from the bottom?
Yeah, as I said, so if you the assignments, the program assignments that are significant portion is already provided to you using Python, you have to use Python. Okay, oh, this is totally familiarize you with the scikit-learn library, for example, which is in Python, then you have to use Python.
Ah, okay, yeah.
Otherwise, you can use, let's say we ask you to implement, let's say the Newton's method, for example, then you can use the MATLAB. It's totally fine. Okay.
Okay.
Yeah.
So because I know that there'll be a plagiarism check, and if we are using code from the internet, let's just say for implementing a model from scikit-learn, so will that be considered as a plagiarized code? Like if we get it?
So basically, we will design the assignment so that if we are familiarized you with scikit-learn, you are just using scikit-learn libraries, all kinds of models.
Okay.
Yeah. Otherwise, basically, we will restrict you, right? So let's say if we ask you to implement Newton's method, you cannot use a scikit-learn's Newton method, right? So otherwise, it's a cheating. Okay.
Yeah, I understood, Professor. Also, my last question. So I just realized that sometimes we are I'm at least losing the connection because of internet. So will you record the sessions? I can see that this is being recorded, and do we also get other sessions?
Yeah, I forgot record. Let's record it from now. Okay, sorry. Yeah.
I think it's already recording.
It's already recording. It's recorded by default then. I think if that is the case, at the end of this course, I will gather recording and I will upload. Okay, so no worry on that. I will upload and share with you guys.
At the end of the video. Okay, yeah.
The end of the course, each class. end of each
Okay.
class,
Yeah.
I will share the link. Yeah, no worries.
Thank you, Professor.
You're welcome. I think I make it automatic. Oh, so yeah, before we move on, I just see July is our TA. Okay, we have two TAs. Another TA has another course right now with, I think, Dr. Zhen, the chairs course. So we can only have July here. Maybe July, you can have a brief introduction yourself, and then we move on. All right.
Hi everyone, I'm Jalal, and I will be the TA for this course, and I'm a student, a PhD student in the computer science department, and this is my second year. Soon we will update the office hour for like it will be virtual meetings for TA. And please, if you have any questions or need any help, you can reach me by email. It's in the syllabus. Thank you.
Okay, thank you, Jalal. So, okay,
Thank you, Professor.
let's continue. So, let me see. Yeah, so what is Python? Python is just a programming language like C++ and R, and so so why is Python desirable? Okay, so the first feature is that it's interpreted. Interpreted means that you don't have to compile the code, right? So then you can do interactive. You type the command and then you run it and you see the results. You tinkle the code, change it a little bit, and then rerun. If you see a bug, you change it. You will see that it's really fast. Okay, so it's basically like MATLAB, right? So you will see that later. Okay, so it also has a lot of advanced features, right? So as I said, Python is really a shell kind of language, but it's different from shell because it's advanced, right? You have advanced feature like object-oriented programming, just like Java and Python, right? So Java and C++, okay, and it's also much higher level. Okay, so there's a lot of containers already built for you, like list and the dictionary, and so like the building the structures. Okay. And by the way, I have a video training my PhD student on those kind of containers, right? So I will also share after the class. So if you have time, you can take a look at it. Yeah, so why we need to use Python, right? So for computer science people, we typically do, let's say, C++ and Java, right? So it's for, and why bother about Python, right? Because Python is fast to code, okay? Much faster to code. Life is short, you need Python. So, and for like math people, usually start from MATLAB because you have so many mathematical operators. You don't care about how they are computed. You just want to call them. So here's because we are from computer science department, let's give a brief introduction, right? So C++ is the fastest language to run, execute once you compile, but the coding productivity is found to be the lowest. Right? So because to handle the deletion, there's a program heap, right? So new and you have to delete. Okay, Java has a garbage collector to help you do that. So it's actually easier to code. A lot of people go to Java. Right? So, and even doing web pages, like Java server page, compared with .NET framework with C#. Right? So, and then, unfortunately, Java is a little bit slower. Okay, in order to match C++ speed, what they have to do is called a JNI, Java Native Interface, which some functions implement in C++. Okay, and so C++ is called a native language. Right, so and Python, a lot of libraries are implementing C++. Okay, so that's why it's fast. I will tell you. So if you program in Python, sometimes it's even faster than Java. Okay, and so like if you use MATLAB, basically MATLAB itself is written in C++. Okay, so down there, everything that is fast, efficient is C++. Okay, and Python is the reverse of C++. Okay, so Python is fast to code, right? You write code is fast because high level, right? But the execution is extremely slow, right? It's intolerable, maybe dozens of times slower. Okay. So does that mean that we cannot use Python? And why data science has to convert to Python? The answer is actually, what you do most of the time is not using Python to write your own algorithm. Okay, what you do is call libraries. And those libraries are written in C, or those compiled components, okay? So here's an example. For example, we have, so there's a bridging tool called Cython, right? So connecting C, compiled to C, and bridging C and Python, right? So, and the Cython has already been used in the libraries. Let's say if you ever use the decision tree in scikit-learn. Scikit-learn basically implements all those models that we teach in this course and a lot of others, okay? And if you look at tree, it's basically unit slicing, right? So that's why down there it runs much faster. If you call decision tree, don't worry, it's slow because they use part of the C language, okay? C proposal. And if you think about you are doing numerical computing, right? So we will have a library called NumPy. So what happens is if you use like you learn the Python language, it's useless basically because it's this language, right? So it's very slow to run, okay? And then we have all those AI machine learning, deep learning libraries right on top, okay? Bridging them is this layer called NumPy, okay? NumPy. And even scikit-learn can take a NumPy library, okay? NumPy others. And what's the difference? So NumPy is hiked in C++, okay, in C, right? So this is many NumPy operations are already implemented in C, so much faster than Python when writing them yourself, okay? And then all those machine learning libraries are on top of NumPy. And we will, after the break, maybe we will have a short, take a short look at the NumPy. I didn't get the time to start the code because I was chairing a workshop the whole day. We will have a 15-minute break at 6, and then I will try to set up the environment, then we will go through. Okay? So try to avoid writing even your for loop if possible, okay? Because for loop in Python is way slower, maybe 30 times, 50 times slower than a for loop in C++. Okay? To understand this, let's take a look at this example. Right? So, for example, this is called a support vector machine, SVM, is a particular machine learning model where you predict Y from the data X. Right? So you will learn this function. This is what we call machine learning. Okay, start with C type branch. This is F is the model, support vector machine. Okay, so C means classification. This is for classification, not regression. We will see what's the classification regression later. Classification basically gives its label, right? Yes or no, cat or dog, this kind of. Okay, so what you do right now in scikit-learn this kind of library, right? So previously people still use like Weka, this kind of model, right? So it's totally outdated. Okay, we will not even touch it. Okay, and so what happens is here we can say, hey, I want a model. Okay, I want a Z model. So you will call scikit-learn, get a model, then you will get this model. Then once you get the model, you just say, hi, predict. I want to predict, and then get the training data, right? Once the model is trained, this theta is totally set. Then you say, hey, model.predict, then you only have the X, right? It will return you Y. Okay. For training, you need to provide both X. Okay? So this is what's happening with scikit-learn, all kinds of models. Basically, it's a unified interface. But I'm not talking about this here, right? So I want to talk about the Python language, right? So why I'm talking about this? Because we look at it here, right? So this is predict. Basically, after you train the model, you want to predict what, right? So what it happens is this, right? So remember we have the x1, x2, x3, right? And then based on this, if model is trained, it will be able to predict y1 value, right? And then you have the second vector, this is x1 vector. Then you have a second x2 vector, it will predict y2, right? So for prediction, it seems that you just needed to give the feature vector to the model, and it tells you the label, right? You don't need a matrix, right? But in scikit-learn, the library is like this, okay? X, it's always a matrix. Basically, what you are doing is, hey, I have 1,000 testing data. I want to get 1,000 labels for them, right? One for each of them. What I will do is 1,000 samples, each with maybe 3 features, okay? I will give it to them. And then I will also get a vector of Y, which is 1,000, okay? Because for each of them, we will get a prediction, okay? So why they are doing this? Because all these are NumPy array. So it calls array-like is because it can be converted to NumPy array. Let's say if you used, I'm not sure whether you are familiar with other libraries like pandas, but pandas, if you load it, it will be a so-called data frame, which is basically a table, right? And the data frame itself is array-like, which means it will, whenever you throw to a scikit-learn library, this kind of libraries, it will convert to NumPy array. And then for everything inside the model, we are working with NumPy array, okay? So this is the concept here. And all those links, you can see more details. So you never write your own for loop. You loop those X and get those Y. You just provide X and get all the Ys together. Okay, any questions so far? If not, let's continue. Okay, so now moving fast forward to the recent maybe 5 to 7 years, we have the TensorFlow, right? PyTorch TensorFlow. Okay, So they are, you know, all the deep learning libraries are in Python. Okay? If you see some deep learning libraries in MATLAB, it's because they are porting everything to MATLAB. And everything in Python is porting from C++. Okay, so this is the path. Okay, because it's just like a shell, but more advanced. Then you are calling, it's like a shell.sh or .bat. Shell is in Linux, bat is in Windows. Okay, we are just calling a bunch of C++ library together and running them together. Okay, and so if you look at the deep learning library, let's say TensorFlow, down there they want to use GPUs, right? And it's all the GPU libraries are in C++, called Cudian, okay, and CUDA. And there's also, if you don't have GPU, just CPU, there's the Argon, which is a high-performance C++ library. It's just like a NumPy. You don't want to write your own matrix multiplication because you don't know the hardware stuff, right? There's cache locality, there's cache line, you access one element and a bunch of elements the same path, okay? So basically, TensorFlow is totally written in C++, okay? It's written in a combination of C++ CUDA. CUDA is totally in C, okay? C or C++, basically, right? And when you call them, actually use Python. Basically, they have the C++ interface, but no one uses them because in the high level, you want to think in Python, right? Or maybe in MATLAB if it's ported in MATLAB, okay? And, but down there, it's actually Python. Okay? Give another example. If you look at the support vector machine, everything is actually ported from a tool that is written in C or C++ called libsvm. It's ported in Python. It's also ported in MATLAB. All right, so why Python wins here? Right. So the first reason is that we have the Jupyter Notebook. Okay, so if you have never heard of it, don't worry, I will go through it today. Right. So previously it's called IPython notebooks, right? And so basically it has the cells and you can run and then you see the results run. You can change the code and run again, and you can add additional notes like text in the same notebook. Okay, we'll see that later. Okay, and this is not only desirable for Python, right? So it's also desirable for MATLAB and also desirable for R. So that's why they rename it into Jupyter Notebook. Right? So they don't want to restrict them as IPython notebook. Right? So IPython is only for Python. So Jupyter Notebooks now also have, let's say, R or MATLAB version. Okay, so you can work with all those kind of interpreted language. Okay, and but again, if you think about it, the library calls are actually in C++. So these are the compiled programs that you are wired to. Okay, Python language itself is interpreted language. Okay, and it lets you write and execute Python code in your browser. Okay, once you create a Jupyter Notebook server, you can just link to that server and using your browser with a URL, and then you can just play with it. Okay, it's easy to tinker with the code and execute in bits and pieces, which means you will write the code and you see, oh, something is wrong, and you try the code and run again. It's really fast. This is in contrast to, let's say, in Java, this is potentially the most painful, right? So you have to do the Maven and compile for 20 minutes, and then you see, oh, there's another bug. And you Maven again, fix it, and then another 20 minutes, right? So that's those kind of Apache project. So Python is totally the reverse of that. Right? Everything is small modules, like so-called microservices these days, right? So, and then you can modularize them and just fix each of them. It's interactive. There's no compilation. Okay? This is really important. Okay, so the first reason why Python wins is really, I think, an important reason is this Jupyter Notebook. Okay, so how to do that? Of course, the first thing is you need to install the Jupyter Notebook program on your computer, right? And these days, you don't have to do that anymore because we have the Google Colab. I would encourage you to check it out. So basically, you have the Google Colab. And if you go to Google Colab, it's already a Jupyter Notebook for you, right? So let's do this Colab. And it will assign virtual machine, assign GPU for you, okay? So Google is basically crazy these days. So you can, once you run something, it will be connected. Okay, and you can also get the GPUs. Okay, I think there's somewhere you can set it. Okay, so let me see. So basically, you can assign GPU to yourself, right? So GPU is totally free. Okay, remember, if you use GPU for deep learning models, it's going to be 60 times faster than running on your own computer, and they are providing free GPUs for you. Okay, So, and they can also connect to Google Drive. So you can put your data on Google Drive and you run everything there. And that's pretty crazy, I would say. So you can use JupyterNotebook. So here, let's briefly go through the JupyterNotebook. Okay, you can add notes, what you are doing, and then you code. If you have a bug, you change the code and run again. Okay, and this is connecting to Google Drive. Okay? So you can put the data. It's like your local drive disk. So, and then you can also run Linux shells. So if you have exclamation marks there, you can run some Linux shell to list the elements in your local machine. Okay, and then these are the Python code. Okay, and so you can also add comments. Okay, so Amulia, do you have any questions?
One fee 8,000 and 8,600.
Yeah, so if you don't have any question, could you mute yourself? Yeah, thank you. Yeah, so.
I do have a question.
Yeah. If you have a question, yeah, just.
Yeah, it looks like, what is the code? What is the comments? Like, what is the machine's response? Is each one of those little lines a line of code?
Oh, yeah, let me briefly introduce what we're talking about. So I'm not going into details of this JupyterNotebook content. I just tell you there's a Google provided service. Once you connect, let's say, let's run this. Once you connect, it will allocate a virtual machine for you. It's totally free, and you will see their GPUs allocated. If not, I think there's some runtime, then you can create GPU. Okay, it's totally free for you, and there's a GPU allocated for CPU and GPU. And it's totally run by Google. It's free. Okay, it's like a free cloud service for you. And this is a notebook. Okay, it's called a Google Notebook, but it's compatible with JupyterNotebook. For example, you can download the notebook as a IPython notebook. Download IPython. Okay, right. So this is a service I want to tell you guys so that you can utilize it without having to install the JupyterNotebook on your own. Okay. And Google, if you have Google Drive and you have a authentication, you can actually connect to them. Those things, actually, we will not cover them because they are all available on YouTube. You can just Google for how to use a Google Colab. It's called Google Colab, okay? And if you just log into your Google Colab, I think I want to kill my session. I don't want next to you. Okay, I think you can create as many sessions as you want, maybe 5 or until they stop you, okay? And so basically, machines, GPUs are all by Google, and this browser is by Google. The downside is you cannot have your machine. You have to use Linux command to see what's under there, where are the disks and files. So this is just a tool that I want to introduce to you guys. So, and if you just start your code, what you can do is, for example, if you start the code, you can start from Google Drive. Let's say you have a JupyterNotebook on the Google Drive, you can click that and run it. Okay, and you can also, let's say you have a GitHub link. You just give the GitHub link of that JupyterNotebook file. It will build the whole environment for you. Okay, and you can, otherwise, if you just want to use it from raw, you can upload a JupyterNotebook file here, and then it will be here, and you can start running. Okay, so this is a tool that you can use without bothering about the JupyterNotebook file on the local machine.
Professor,
yeah.
So in order to utilize the capacity of the GPUs, so do we have to write, I mean, like make any changes to the Python code, or is it going to be same?
Oh, so if you want to use GPU, you usually don't include the programming. That's too low level. So usually what you call the libraries themselves will use GPU. Okay, let's say you TensorFlow and you say, TensorFlow, you should use GPU. They will use GPU for you. Okay? It's kind of transparent to you. It's okay?
Yeah.
In this course, we will not use GPU most of the time unless we run some libraries. And then again, the GPU are low-level stuff. They're already handled by Python library for you. Okay, if they detect you have GPU, they will use it. Right?
Okay. So I'm just curious to know if the Colab uses the local resources like my laptop resources or any cloud server resources.
It's totally cloud. It's totally cloud. Right? And the disk associated with your virtual machine that is assigned by Google is Google Drive. Okay, so maybe this is the way they make money, because Google Drive by default 15 GB, right? If you want to pay more, yeah. Otherwise, I don't see why they are providing this free service. Okay, yeah. So just to let you know. But,
probably trying to collect our data too.
Yeah,
that's true.
Yeah, so you can upload things here. You can put in your Google Drive, and then you can manipulate it. Let's say for example, I put something into Google Drive, and then I can use Linux command to see, hey, what's a local home and where the disk, and I see the path. I can say, hey, load this file into Python. Yeah. So again, those are low-level stuff, not relevant to our course. So if you want to explore more, you can take a look at the Google Colab. Right.
Also, as you mentioned, Professor, are we also going to deal with learn TensorFlow and all? Because I know
No,
that TensorFlow is used for deep
it's
learning.
not in this course, but we potentially will have you directly give some libraries for you. Okay, so TensorFlow means you want to change the deep learning model, right? Otherwise, maybe you will change the last layer, because your problem is transfer learning from 3-class problem to 5-class problem. Then we will touch a little bit of that, but we will not delve into TensorFlow.
Okay.
Because we have another course called deep learning. That course of responsibility. Right. So
Okay.
even though that course may not cover that, but yeah. So I think there's tutorials online. That's out of the scope of the machine learning course. It should be deep learning. It's okay.
Yeah. Sure. Thanks, Professor.
You're welcome. So once you install the Jupyter Notebook software, right? So you type that command Jupyter Notebook, it will start the Jupyter Notebook server for you, right? And in your browser, if you click a localhost 8888 support number by default, okay? And it will start a Jupyter Notebook in your browser. I will demo that shortly, okay? And here is a Jupyter Notebook file you will see, right? So you can create a new Jupyter Notebook file here. If you click, let's say, Jupyter Notebook file, Python, right? So you can create other files. Maybe R, I'm not sure. Okay, and if you create a new Python 3 Jupyter Notebook file, for example, right, we will stick to Python 3, and then it will show in this folder, right? So what is this folder? Okay, so you can CD to somewhere in your computer, right? Let's say you CD to this directory. Okay, if you type the Jupyter Notebook server, right, then you can access everything down in your file system structure. Okay, everything here. The root folder is exactly where you start your Jupyter Notebook. Okay, so there are students asking me, early on, so how they have another code to download to their download folder, right? They have to copy some things here and there. So the answer is simple. Where you start your Jupyter Notebook server, this is your root folder. You can access everything down there in the folder structure. Okay, nothing outside the folder. It's just like your web server, PHP, Java server page, or Tomcat. Okay, where you start the root folder is where you start the server folder. Okay. And here a notebook is made up of cells. Right? So what is cells? Okay, so this is a cell. Right? So the second one is also a cell. Right? Each cell can have different functions. Right? So one can be simply code that you want to run. There's also another thing called Markdown, which means you want to take note. Markdown has some simple grammar, but I think you can Google, and it's really simple. It's maybe some like how to use boldface. You use to sharp, and then everything in between is boldface. Okay, so basically there's something there that you need to know, but you can easily Google it. So these are the cells, and when you want to add a new cell, plus you will have a new cell. And you can come back and check both cells. Only one cell will be active each time that you can run. For example, if you run this cell, how to run this cell? There are two methods to run the cell. One is click this run button when this cell is active. The second is really what we use most, shift and enter. Okay, you can look at your keyboard, and you can see that the shift and enter is really close, right? It's just in the same column, okay? It's a shortcut. Okay, so another thing you need to pay attention is that Python, MATLAB, R, they are the same thing, basically. Okay, so it's just a different language. So global variables, so whatever you define, you don't need to specify. Let's say if you are familiar with Java or C++, when you say, hey, integer x, right? 1, 2, 1 plus 1, right? In Python, you don't need to do that. And then you can even change its type. Later, you can give it a string. Right? Type change to string. Okay? Right. So pay attention to that. So here you define x. Okay. So you define x equal to 1 plus 1. And if you do that, if you print it, by the way, in Python 3, we have print becomes a function. So you have to use parentheses. Here it's a copy function. Right. If you print it, it will be 2, right? Because it's a 2. But in the meanwhile, x is in the global memory. Before you delete it, you call DLX, it will always be there. That's why in the second cell, you say, hey, 2 times x, right? Because x is already 2 times x, y becomes 4, right? Then you will see another y, which has a value 4 here, x is 2. So if you want some better intuition of what this is happening, right, let's look at the counterpart in, let's say, other tools. One is MATLAB. Let's say. Right, so in MATLAB, if you define something like x and y, they will appear right here, okay? So they are global, they are always here, okay? If you define another x and y, they are all listed here. Unless you say, hey, I want to remove this from memory because I don't have enough memory to hold it. It's useless, right? So you need to do it. It's the same in Python, okay? Again, you can foresee that all the future deep learning tools will all be in Python. So that's why we just go straight with Python. Everything is going to be Python, unfortunately. Unless you are doing the down-level libraries, which you need to know C++. So only 2 languages matters in the future, C++ and Python, okay? High level is Python, low level is C++. All right, so after you modify the notebook, right, so you change something, then you want to execute something else. Right? So what you do is, you want to save the change. Right? So one thing you can do is, I think there's a save button here. Right? So if you look at here, there's a save button. Okay. And another way is that you can go to the, what I show here, you can file and save and check it. Okay. That's what you save. Otherwise, it will not be saved. Okay. Because these are just output stream. Whatever you run, they will basically redirect the console output to the output here down here. Okay, so this is the console output. Okay. And so for any file that is IPYNB, right? So like this type, okay, you cannot directly open it without using a browser with the help of Jupyter Notebook Server. Okay, the Jupyter Notebook Server will help you translate it into a browser readable web page. Okay, without that, you cannot do that. Okay, it's a JSON file. So this is not user friendly, right? So if you you've done something and then you have a report, right? So you want to, because every step you can add some comments. Basically the whole operation history, trial history will be there in YouTube. Then you want to send to your boss, for example, right? So you can download it as HTML, right? And it will translate it directly to HTML file, and your boss will be able to read it. Okay, it's every step, what code you do, your comments or notes, etc. Right. So this is what we will stick to in this course. Okay, so basically when you submit your assignment, you can submit to IPYNB, it's fine. But please help us also save to HTML, upload the HTML file, right? Otherwise the TA has to include the IPYNB file to his Jupyter server folder and then read it. Right? It will be super painful. Okay, if you have HTML file directly, the TA will be able to mark it either. Okay, so how to get started? Of course, you can do that offline. So the first thing is you want to install Anaconda, right? So why we want to install Anaconda? So this is called a virtual environment. Okay? It handles package dependencies. So let's say your operating system, I use this, yeah, this is fine. Operating system, right? Mac OS or the Windows, right? On top of it, maybe you will install your Python version, right? Unfortunately, this kind of open source libraries, right? Open free software, they do not consider backward compatibility, right? So because you have to use them or you tune to them, they do whatever they want. So they have a Python 3, okay, PY3, and that's totally, a lot of things are incompatible with Python 2. So Python 2 code sometimes cannot run in Python 3, Python 3 cannot run in Python 2. So that's a dilemma. So in your operating system, what do you install, Python 2 or Python 3, right? So the solution is to install a virtual environment using Anaconda, okay? And then if you need Python 2, you create a virtual environment in Python 2, on top you install Python 2. If you want a Python 3, you create a virtual environment in Python 3 and you install Python Then if you want to, you have some Python 2 code, you access this environment to enter this environment, right? Okay? And then you have some Python 3 code you want to run. You access here and come here, this environment. Okay? So this is what we talk about handle package dependencies. So there's a lot of packages down there in each Python. Okay? Let me quickly go through. Okay. So how to create a virtual environment? So the first thing is that you go to this link. Okay, so this link download here. Okay. After you download, it will automatically detect which operating system version you are using and get the user package. And you just download and double click and it will install it. Right. After install it, then this command should already be in your operating system. If not, you need to Google and see how to add the virtual environment to your operating system. By the way, so the command may change a little bit on Windows. All here are tests on Mac. Okay, so you just Google and Stack Overflow will tell you, hey, maybe it's not on Conda Create, it's Conda Make or something. Okay, so you need to, if you are using Windows, pay attention to these small details. Right? So maybe it's still Conda Create, but there's somewhere else things will be a little bit different. Okay, and so you say using the Conda environment, right? So Conda software program, you want to create a virtual environment called Anaconda. You can use any name, like your name, right? You can give different environment, different name. Here you can say, I want to use Python 3.6. Let's stick to Python 3 because it's the trend. Python 2 is outdated and stopped maintaining. Okay. And so here, oh no, so actually this is a -n name. Name is your virtual environment. Okay, it's not Anaconda. Anaconda is basically say, hey, configure the Anaconda. So it will install the dependency packages, including Jupyter Notebook. Right. So that when you enter this virtual environment called this name, it will. You don't have to install Anaconda. Jupyter Notebook, it will be there for you already. And once you create this name in virtual environment with this name, right? So how do you start this environment? You source activate, okay? And then you will be able to enter that virtual environment, right? And then the environment libraries will be loaded. Right. Now, if you want to leave the environment, you don't want the Python 2 libraries, you want to enter the Python 3 library. And so then you say source deactivate, okay? So then you leave the virtual environment. And you can enter another using another name. So this first name is Python 2, second is Python 3. Okay, and pay attention. So I don't remember the detail of the command, but if you are using Windows, I think this is the same, but the source activate and deactivate will change. It's maybe not activate, it's somewhere else. Okay, you need to Google and make sure you are using the right command. Yeah, so I will do 2 demos after the break because it's almost 6. Okay, so it's already 6, right? So we will demo the Python notebook, and then we will demo libraries. So this is the second reason. The first reason is Jupyter Notebook. Right? The second is really you have so many libraries that's written in C and made available in Python API and for you to call. Okay, we will take a look at it. Right? So basically, we are calling that this is convergent design solutions. Basically, all future libraries will be written in Python. They all open up Python API. Right? And and we will also share the demos in online, right, Canvas, okay, and you can download and play with yourself. And I do recommend you to play with yourself. I will set the environment in the next 15 minutes where you will take a break, okay, then we will continue. So we will come back in 6:15. Okay. Thank you, everyone. Any questions? I will stay online for 2 more minutes and you can ask. Okay.
I have a quick question. Is there any kind of, I know in Teams they got like a hand raise or something. Any way to do that on here?
Can you repeat your question?
You know, on Microsoft Teams, they have where you can raise your hand. Do they have anything like that on here? Or is it just every man for himself when he has a question?
No,
I think there's a hand, raise hand button there, right? So do you see that? I guess it's more if you don't see that.
I do not see it on mine.
I think, Professor, you have to click on the participants. So only when you open the participants tab, then you can see raise hand, yes, no, go slower, go faster, something.
Yeah,
like
I understand, but I think his question is how he can raise hand, not how I can see.
Oh no, that was it. That was it. I also have one more quick question. Okay. If we do want to download the Jupyter, if you go to jupyter.org, it's got the classic notebook and the Try Jupyter Lab. Which one would we download?
I would say stick with the classical Jupyter notebook.
Okay, with the classic?
Yeah, it's just the Jupyter notebook tools. So you
Okay.
download the Anaconda, that will be the complete package. I think both are fine. Basically, the rest contains the form, right? So all we need is Jupyter Notebook. Okay, but you can download the whole Jupyter software. That's also a choice if you have enough of this.
Okay, thanks.
You're welcome. Yeah, I see that in the chat function, right? So Staff Saeed told that there's a raise hand function. Okay, if you have questions, just raise hand. But again, we have too many students. It's really difficult to see, for me to see through 100 students, see where the hand. Okay, so I would say just unmute yourself and let me know. Okay, so as long as not everyone is doing that, it's not so frequent, that's fine. You just unmute and ask a question. Right. Okay, so I will stop share and prepare the demo environment. And yeah, so let's take a 10-minute break from now on. Okay, and then come back. Share.
Coraline is not a Halloween movie.
Hi.
It's not. It's a family love story.
It's still a Halloween movie because it's a scary cartoon.
So, Halloween isn't that scary.
Yes, it is.
So if it was already Halloween, would there be walking?
They're not.
So if it was Halloween already and like we went trick or treating and it was so scary.
I want
Yeah, so I think if you can mute yourself first. Okay, so because everyone can hear, so maybe it's privacy that you want to protect. Okay, thank you. Okay, let's begin. I think, yeah, how many students we have? Maybe we will still wait for 1 minute. So because this course is not totally for demo, this Jupyter Notebook is very long. Okay. If we just a demo how to program, then it becomes a low profile programming course, which will take you like a valuable time in the lecture. Okay, so what we'll do is really a quick go through of the Jupyter Notebooks. And then because they will be shared online, right? So you can go through them yourself, right? So let me tell you the location, right? So here I keep the, I like the simple style, right? So the home and the syllabus, right? So they have the same page, right? And you can download. So the demo code is here, right? And all these files, you can easily download them here also, right? So
Professor, we
yeah.
can't see a screen.
What?
It's not screen sharing.
Oh, sorry. Yeah, let me, thank you for the reminder. So here's the Canvas page, right? So in our website, it's super simple, right? So a lot of professors want to make it super difficult to use with a lot of fancy tools, but really all we need is each day where you get all the files, right? And you can download it from demo code, right? Python slides and the course overview, and then we will go into the introduction to it, okay? And there's some mathematical notes here that you can download. All these files are also here. If you click the file tab, you will find all of them. So basically you can also download from the Zoom download, right? So you can see the attendance and our Zoom link. And so here people, you can see other people. I'm not sure because maybe I can't see all of you guys, but because of the anonymity requirement, but you can only see yourself. Right, so there's a grade. Okay, so you will see how well you do. I will see everyone, how everyone do. Then I can send it. Okay, so that's the simple structure. Okay, to come to the dynamic syllabus, and before each class, I will release the slides and the related documents, and you will download them, right? And then you, if you have assignment, you will see the assignments in here. Right now, we don't have any. Potentially, I will have some from next week. Okay, so and yeah, so that's pretty much the simple structure that you can get your files. Okay, so and assignments. I think I should have created the assignment scheme. Okay, so yeah, I forgot to do that. So basically, we have 4 categories, just mentioned as we mentioned in the first slide. Okay, yeah, so that's pretty much it. And if you download this demo code, it will be something like this. And double click or you zip, you will get here, right? So we have 2 demos. One is really just to tell you the basic Python and also some NumPy library. Okay, the second is a library called scikit-learn, how to do machine learning libraries. Okay, so let's take a quick overview of these, right? So for example, if you want to create a Jupyter Notebook, right? So you can either install it on your machine, just like what I did. Another way is you install the Anaconda environment, right? And then enter the virtual environment. If you create it using Anaconda, it will the slides. Yeah, if you use the previous slide I showed before, right? So if you use I think it should be in this slide. Okay. I think where is it? Yeah, if you create using this command, it will have some standard Anaconda packages installed, okay, including scikit-learn, including the Jupyter Notebook. Okay, so then you don't have to even install Jupyter Notebook. If you create this and then you enter the environment, okay, then Jupyter Notebook can be directly run, okay, because it loaded like. Okay. Here, for example, if you enter this demo, let's say here I want to use this as a root folder. Right? I open terminal as a folder. You can see I have two files down here. Okay. Demo and demo 2. Right? So then I want to further into the next demo, right? CD demos. Yeah. Then I see this. Right. Starting from here, I want to make it the root folder of our Jupyter Notebook. Right? So I keep it notebook, and I will enter. Okay, and this is the server side of console. This is client side. We will see these two. Okay, and what you do is you can go through those different levels. Right. So again, so this is the basic Python language familiarization for yourself to go through. If you never learned Python, that could be a little bit troublesome. Otherwise, it should be fine. So basically, in Python, you know, so you can also not just run Python code. IPyNotebook also supports, let's say, list, which are those files. Okay, those files inside. Okay, and you can run, you know, the console command. And if you use JavaScript, you can run JavaScript command, right? So because basically, you know, JavaScript is manipulating the DOM in your browser, right? It's a web page. The JavaScript will do something on the cells. Okay, for example, this cell clear all objects, right? Including this object. That's something. Okay, if we run this, it will clear. So in all the assignment I will give to you guys, don't run this after the first time, right? So otherwise, all your workload will be cleared. Okay, so pay attention to that. But I included that because I want to do some tests, and then, you know, if you want, you can remove it. Okay, so then I can clear them so that you can. Okay, so you can delete a cell, then it's deleted. Right. So here you can run it. Let's say you create a x equal to 3 and type a print x, and for each variable you can also select type. Okay. And now you are in this cell, you can run this run, okay? And you can see 3 and it's integer, right? And you can also do something like, let's see how to say it. So basically, then you can do something again. Let's say you can make it a string. In Python, single quotation, the double quotation is the same, okay? So then you can do this again. You can see you don't really need to define any types, okay? You can do this. But even more, if you know object-oriented language, right? So you can. I'm not sure. Maybe because it's already a string, you cannot do that. Yeah, it's will report error. If you see something error happens, you can fix it, right? Immediately. So that's to tinker your code, right? It's very easy to use. And if you look at it, this is the added cell that is code, right? So this is the Markdown. Okay, in Markdown you can have some. Let's say if I want Python to be highlighted, I can use this. And then it will be highlighted. There's some Markdown grammar that you can Google easily, right? Wikipedia. And like here, you have the start, and so basically, I always just use code and Markdown. The others, maybe you can try it. Okay. And basically, you say what you are doing, and then you do something. It's a good way of tracking what you did, or even make tutorials to people. Okay. So here, I will not go through each of them because it's kind of basic stuff, right? Like those operators. This is to the power of 2. Okay, so it's 3 to the power of 2. Okay, and let me quickly go through and find something interesting. A print, you can print multiple things. They will add a space in between. Okay, and Python has no plus plus. Okay, no plus plus. All you can do is, let's say x. So by the way, if you have last line, okay, it will print the last line. Okay, if you want to print all of them, you need to use print. Okay, if you use print, it will print it several times. Otherwise, the last variable will be print. Okay, and here you print 3 times because then the output will be print. Okay, this is the output side. And let me see if we add this word print. No, it will not print. So this is similar to MATLAB, right? So if you don't have this notation, it will print the last variable that you run. Okay, so let me see anything interesting. Python true and false should be uppercase, right? So it's a bool type. Okay, so this is an and or not equal. And Python strings and string you can use plus. It's just like in Java. Right. So what's different from Java is this, right? So you cannot add string to a default. Okay, so you need to say hey string. Okay, it will change. There are a lot of things, right? The uppercase, etc. So I don't have time to go through all of them. What I think is important is containers. Okay, so containers are the concept like list is an array, basically. Okay, and so let's say if you define 3, 1, 2 a list. By the way, if you use an array, a list, you need to use this bracket. Okay, and then actually, if you look at the indices here, right? So Python using the same indices as C++ and Java. Okay, this is position 0, position 1, position 2. That's why if you guess position 2, it will be 2. Okay. MATLAB starts from 1. Python from 0. Okay. And the -1. Okay, what is -1? The -1 means I count from the backwards, and the first one is 2. Okay. So anyone who knows what will be -2?
It'd be 1.
Yeah, it will be 1. Okay, because you count backwards. -1, -2. Right. So I think I don't want to go through all of them. So there is a append operation. So you can change its size, but the most efficient way is to append elements to the end. Okay, so this is I think this is like C++ vector or Java's array list, right? So if you copy, and if this is the 4 space, you will double the space, and copy this here, and then add the elements here. Right. So for these data structure related stuff, let me send you a link so that you can get some deeper understanding. Okay, so I would just maybe share it on chat. So let me know if you cannot get it. Okay. Channel.
Kamala Harris ran for
I think this is my channel. Oh, I clicked that advertisement. And so, yeah, so they're the ones.
They are all rather to look at. Okay. Previously, we talked about things, a lot of them like the.
So basically, these are all data structures. Okay, we call them containers. So they are all, if you run algorithm data structure, they are all basically have counterpart there. I will share it so that if you have interest, you can go through it. It's pretty long video. Yeah, but if you watch it, you definitely will learn a lot. Okay, so let me see whether I can set the chat. Yeah, so if you click this, you will be able to watch the video offline. Okay. And it's maybe more than 2 hours, 2 to 3 hours. Okay, so this is basically what I give training for my PhD student to make sure they can code in C++ and maybe also Java and Python. Okay, so you can take a look if you have time. And yeah, so basically, this kind of array, this list, the most efficient operation is append and pop. Take something in the middle, it's very slow. And there's also a way called slicing. Right? So 2 to 4. Okay, so basically what you do is, let's say you have elements this, 2 to 4 is 0, 1, 2, right? 2, 3, 4. But 4 is not inclusive, by the way, right? So keep in mind in all programming languages, not just Python. Okay, this is inclusive, this is exclusive. Right? So this is 0, 1, 2, 3, 4. Right? 2 to 4 means from the second position to the third position, not including the first position. Okay, this is the smaller line. So this is the larger line. Okay. I think the others we can quickly skip them. And there's a notation called list comprehension. You can do something like this. You can have a for loop for each x in this NumPy array. Right? You can do square. And if you do this, you will get something like array m square. Okay. And you can even add conditions, let's say, only for odd numbers. So the next thing you need to know in Python is dictionary. Okay. It's the key value pairs. Right? So for example, you have cat, cute, dog, furry. Right? This is key, this is value. Right? And then hey, give me the cat. Right? So the value is cute. Okay. And the cat is in the dictionary. When you say in, it only looks at this, it's a set of keys. Okay. Cat or dog. Okay. You use dog, it's also right. But if you use cute, it's a value that's like okay, so these are the minor details about Python that you can go through yourself. So this is basically hash table, right? Because you don't want to scan the whole table. Okay, so there's also a concept called set. Set and the dictionary all having the brackets. Okay, the only difference is that you have key value for here, and for set you don't have key, you don't have value. So that's the only difference. And you can iterate through them. Basically, the file is there, so you can go through that yourself, right? So, by the way, stay with me. I will really finish this maybe in 10 minutes. Then I will go to machine learning stuff. Okay, so I just quickly go through them, and then then let you do that one. Okay, and there will be tuples, right? So tuples is then using this parentheses. It's not a bracket. Okay, so something like this. It's a tuple. Okay, so pay attention that if you have one element, okay, in the tuple, you need to have a comma here. Then it knows it's a tuple. Okay. For example, if we say type, and parentheses can be omitted, but the comma cannot be omitted. Okay, so you have to have this. Let me see. You have to have this tuple, right? If you don't have this, it becomes integer, right? So, okay, so because one add parentheses here, you have to have this comma, and with parentheses, it knows it's a tuple, right? Stuff from 2 or 3, you don't have to do that because there are no ambiguity with the integer, right? Because you have more than one element. And yeah, so you can use length. Length basically get the object's size. Let's say for singleton, right? So if you get the size of empty, it's the size 0, right? If you get the size of singleton, comma, this is the tuple. You want to have one item, okay? But if you don't have this, this becomes a string. You will get 5, okay? So pay attention to these low-level details, and you can define functions, etc. Okay, so you can define object-oriented programming class, right? So I will really go through. Okay. Then you have the NumPy, okay? NumPy is now high-dimensional array. For example, if you create a one-dimensional array, oh, NumPy is not, yeah. Import NumPy as NP, okay? I don't need to re-emphasize the importance of NumPy, right? So Python is nothing without NumPy. All data science libraries are built on top of NumPy. And NumPy is built on top of Python, okay? And they use a lot of C#, okay? So it's a NumPy array of the shape, right? So you can type, this is actually a one-dimensional array with 3 elements, okay? So, and 1, 2, 3, right? So this is a shape, basically. So this is type is here. Shape is a tuple because you can have 2 dimensions, right? So for example, if you have something here, right? You can do the v.shape, right? Then it becomes 2 dimensions, 2 and 3, right? So, 3 columns, 2 rows, okay? So, and there's a lot of important stuff. I want to go into details, okay? So I will leave it to you guys, but do pay attention, right? So NumPy, when you do the NumPy operations, it's much faster than if you write your own operation. Okay, this is the dot product, the product of 2 matrices, etc. Okay, and a lot of linear algebra operations are there, and way more operations than you can imagine, right? So it's better you go through this. This will cover you a very small fraction of the operations that are very frequently used, okay? And so if you go through that, you will have basic technique that is necessary for this course. So we will not go deeper in Python. Right? So just all of these are necessary, okay? But no need to know more, right? So, but if you don't go through this, you have questioning here and there. So for this week, we will not mark this assignment, but please go through it, okay, yourself. So this familiarize with you about what is Python. Right? So this is one thing, and then yeah, we don't want to spend the rest of the class for going through language. Okay, so here another important library is called scikit-learn. Right? So what is that? So this implements all the, so when you import, it's actually called sklearn, but the library itself is called scikit. Okay, so sklearn. You can import different kind of models. SVM is a support vector machine, is one kind of model. The same tree is another, right? So neural network is another, right? And not deep learning neural network. It's a simple feed-forward neural network. There's no like the recurrent neural network, the convolution neural network, okay? And so let's go through this example quickly and let you see what scikit-learn can do, right? So basically what we have is this CSV data set. Right? So what it has is basically this x1, x2, x3, right? So the different, like the second is date, right? So the first is maybe ID, okay, the season, maybe there are 4 seasons, that's 3, 4, okay, 4 seasons. And there's a particular attribute that we care about, right? So this is a count. So this is like a bike sharing service, right? So how many people will rent a bike in a station if your station feature has something like this, okay? So from X, we want to predict Y, it's a count, okay? So this will be, let me see, this will be the regression. So let's just go to the regression problem, okay? Yeah, so another library you need to know is called pandas, right? Why you need the pandas? Because you can load this CSV file just with one line. And you say, I only care about Stephen. Like, ID is not important, right? One, because this is station 1, that is station 10, that impacts your count, right? So the ID itself doesn't matter. It's more like, hey, this station is in a residential area, that is in a business center, another is in a rural area, right? So that will impact the count, right? So ID will be removed, right? So we only care about those things. And then we load it. Okay, so then we have a table, right, and see the attributes item. Right, so this is called the pandas data frame. It's mainly for this kind of table that we manipulate. Right, so what we do is we can shuffle them, because if we don't shuffle them, sometimes sometimes you will have class 1, 2, 3 stacked, right? So then you cut them, then you only see class 1 and 2, and the test data is all 3. That's not what you want. Okay. So you can do some sampling, shuffling, then this data will be totally shuffled. Okay, it's still this data, but the ID are running. Okay, and then you can say, hey, I wanted the first 70% of the data to be here, right? So I lock it because the data set is a data frame. Okay? It's a data frame. Okay, so this is how you take the row. I will share this Supernova file there already, I think, right? So you can go through it yourself. Right? So then you can drop those indices. But after drop, it will become 0, 1 again. Okay, and then you can say, hey, I want to how many to be training, how many to be testing data, right? And the -1 is saying, hey, the last column, right? Counting from the bottom, the last column are the Y. Okay, right? So all the others are the X. Okay, right? So we will see. So Y is just so many columns of numbers, and X is not only those, so it cares about those 5 attributes. So it's so many rows and those attributes. Okay, and we split the data into 511 as for training and 220 for testing. Okay, and this is what we are doing. So just using the index. So if you go into NumPy, and basically data frame is kind of similar to NumPy. They are the same thing. And then you can train. Train is super simple. Right? So you include scikit-learn and import whatever model you want. And then you say, hey, SVM, you have the regression classification. I want a regression model, and give the model parameters. These are called hyperparameters. Human has to set them. Right? So in the model itself, it has also parameters, which is what the model learns. Right? So the optimized parameters. Okay, automatically learned. But there are some parameters that human has to specify. Okay, and then based on that, defines the optimization problem that model can limit to minimize the error, okay, of your Y when you see those X, right? So then you give the training and the X that you already have those labels. Training, this is the labels, Y. Okay, so basically you're giving those X, and then get this column Y, okay? And it will train the support vector machine models. So all you need to do is just fit. After fit the model parameter set, and then you can predict. And here you only need to get X, because Y will be predictable, right? So here the test data, you just get those attributes. The Y's, these are the ground truths, but then you need to come back and compare the predict value Y and those ground truths Y, right? So here is a way you can use NumPy to do that, mean square error, but actually scikit-learn itself has a lot of metrics to do that. Okay, scikit-learn. So again, in Python, everything is just calling libraries. Okay, so writing your own code is no merit. Okay, get familiar with Python libraries, and the libraries are faster. Okay, don't even write your own code. So let me see. Yeah, here are the metrics. Right? So you probably will use accuracy, or you use AUC curve, etc. ROC curve, precision, recall, loss. So I think there's also something like a regression metric, right? Mean square error. Right? So you can call this, get the true ground truth and the predict value. Right? So here we are just writing our own. Right? So this is for a demo. This is predict value. This is true value. Okay, and then we see how different it is. Okay, so yeah, so that's it. And you can also do a grid search, right? Because you know, so you have hyperparameters. So machine learning model has 2 sets of parameters. Okay, so one is called hyperparameter. You define them, then you define your model. Okay, and then the model itself has some parameters that is what you are actually training. Right? So, for example, if you train this model, right? So you first define hyperparameter. Okay, after hyperparameter, the model also has some parameters to train, and this is where you learn from X and Y. Okay. After that, the model is here. Okay, simple. After that, the parameter set, then you just learn the parameter. You put using X, you put the output Y. So this is the machine learning, right? So supervised learning. And then research really say, hey, I don't know whether these hyperparameters are well chosen, right? So this, unfortunately, optimization cannot do that for you. Okay, this is when you define the problem. So what you can do is you try different possibilities, right? So different combinations of these values and see which one is the best, okay? There will also be a concept called cross-validation, basically CV, right? So we will cover all those things very soon. Okay, so I will not go through these. Okay, so yeah, so one is for classification, one is for regression. So classification is saying that regression is basically predict one value, let's say the count, right? And how different is the true count and the predicted count. And classification is basically saying that the data is something like this, okay? So these are the labels, okay? This is the target. Right? So by the way, so scikit-learn itself has some toy data sets you can play with, okay? So like in the data set, you have the iris data, and then these are the targets, these are the Y. Okay, you can also get X. Okay, so these are the data and the target Y, data X. Okay? And then you can train. So you can see that you have 3 classes of iris, right? So 1, 0, 1, 2. So this is classification, right? So cat or dog, 0 or 1, 0 or 2. K-class classification, this is called classification. If you predict one value, let's say temperature, count, etc., that's regression. Okay. So yeah, maybe we can make this clear, right? So this is called supervised learning because when you train, you provide both X and Y. Then you call it or train, right? And then you test, you just provide X. You say test or predict. Okay, then that's a predicted one. Okay, so this is called supervised learning. And here, if this is just one continuous value, or even count, right? So this is regression, okay? If this is whether it's the class 1 or class 2 or class 3, right? This is classification, okay? And the model itself has a parameter. That's what the model is training. It's called the parameter, right? And for defining this function itself, you also have some hyperparameter, okay? Hyperparameter, okay? Yeah, so that's pretty much what is covered in these 2 Jupyter Notebook files. And for this week, right, so your task is to go through these 2 demos. Right, so again, it's your choice. So we want to max them, right? So, but I don't want to stop emphasize how important it is. Okay, so basically, if you are in data science, this should be common sense. Okay, so if you're not familiar with Horizon, this is the one shot that you can quickly understand stuff, okay? Because we will have 50% mainly mathematics and 50% hands-on. Hands-on, we will no longer go through these low-level details. Yeah, let's continue. So yeah, do that offline yourself, okay? And so yeah, so this is the Python language demo I just did. The second is really the library. Right? So we see pandas, which is to manipulate the table, and then you do data cleansing. Right? Remove some data cleansing, a lot of data cleansing in pandas. Okay. After that's clean, now you can get to, let's say, scikit-learn. Right. So yeah, scikit-learn, and then you can do machine learning. Right. And all scikit-learn is built on top of NumPy. Okay. And pandas table can be taken by scikit-learn because pandas data frame is array-like. So it can be converted into a NumPy array, okay? And then also if you plot images, you use matplotlib, okay? So matplotlib.pyplot. Okay, these are 4 libraries that you have to know, okay? If you don't know, then you're in trouble, okay? So, but you don't know, then you need to spend this week, get familiarized with them, Google and watch videos, etc. Okay. And another kind of library is called TensorFlow and PyTorch. Okay. What are they? So you have seen that we in machine learning, what we are doing a lot of the time in supervised learning. So we are having a model function, which is which is the model, and we have the input data we want to predict Y. Okay. In order to do that, we will say what's the true Y, right? So what's the predict Y hat? Okay, and we want to minimize that difference. So this becomes an optimization problem, how to find the best theta. Because this is your data you see, right? This is the true label you see, right? This is your predict model from the model, right? So how to find, because there are so many parameters you can choose. You want to find the parameter that minimize the difference, okay? So this is just high level stuff, right? So previously you need to do a lot of calculus, right? High dimensional calculus, because this could be a vector, this could be a matrix, right? So we will cover some of them, okay, the simple ones to give you a feeling, a taste. We will not go really deep like in machine learning people like ICML and NIPS researchers, I say. But it's important that you understand what's happening so that you go beyond the shallow scikit-learn caller, okay, which is like easily replaceable. Like once you go through those deep notebook files, you can find a student doing those things, right? So, or find an employee doing that, right? So like COVID-19 and this layoff and potentially these people without deep understanding will be the first batch, okay? And so TensorFlow and PyTorch, what it does is it automates this optimization for you. You say, hey, I want to use an optimizer to gradient descent. You help me compute the theta. I don't want to calculate the gradients, right? So I don't want to do gradient descent. I don't want to do the optimization myself. I just tell you what is the F function, and then you do the optimizing for me yourself. Right? I don't want to touch math, okay? This is where the TensorFlow and the PyTorch comes in. So that's why now people are all moving in this direction, because you don't need math, you can still do machine, right? And then there's also domain-specific language. Let's say for natural language processing, there's a NLTK for parsing, part of speech, this kind of tools, right? So the tokenizer, and there's also libraries like Jensen, which is for topic modeling, LDA, and Word2Vec, this kind of stuff. Okay, Word2Vec is basically you have a document, right? Each word cannot directly go into machine learning model. We have seen that machine learning model only takes vectors, right? X1, X2, X3. So Word2Vec is a way that makes each word a vector, but in a reasonable way, right? Because it's learned from a lot of documents, corpus, okay? And now there's a more advanced model like transformers, etc. But we will not cover them. It's a duty of the deep learning course, okay? And so yes, this is a convergent data science solution. Everything just put in Python, right? But it's actually in C++, okay? It's just a Python libraries with Python API, the C++ core, the programming. Okay? Some of them are actually in Python, by the way, right? So top level, because if your NumPy is already in C++, and then on top of there, you can just write Python code, right? So there's part hybrid Python, like it's hybrid, I have to say, okay? It's not totally C++. Yeah, so this is the second demo. So basically it goes through the pandas to load the data, and we don't have data cleaning because data is quite clean, okay? And then we do scikit-learn for support action machine. Yeah, and it goes through them yourself. This is really important. We will not check, but you need to know every detail, right? So think why each cell, what does it mean, and familiarize yourself with it, okay? I don't want to emphasize more on why it's so important. Yeah, it's not the purpose of this course, okay? It's preliminaries. Any questions before I move on to the introduction of the course? If not, let's move on, okay? Yeah, so for the first part, we will familiarize you with some, mainly the machine learning terminology to build a mindset as a professional machine learner, okay? So there's no real stuff, except maybe one mathematics stuff, okay? Other things are mainly conceptual. So today will be relatively easy, okay? So let's begin. So let me see. So what is machine learning? So machine learning is a science of making computer artifacts, or we can say computer programs, improve their performance, models, okay? But you want to do that without, without you code it, right? So it's like if you have a SQL, you have a database, you want to get everyone whose salary is more than 5,000, right? So you can write a SQL code for that, right? So this is not what we want, right? So our model, our artifacts should learn, certain criteria, right? Let's say minimize prediction difference from the ground truth. Right? So certain problem using example data or past experience. That's what you see in the first example, right? Fit X and Y, okay? And once you learn, then next time you see an X, you know, you can predict Y with reasonable accuracy, okay? So without requiring human to program that, it's not like you write a code, like a SQL query or C++ code. It's just you give the data and it learns from the model we're learning. You learn parameters from the data, okay? And then you can use the model. And there's also other terminology, right? So data mining. So what is data mining? So the people like carbon mining, right? So there's a researcher, I think at Jiawei Han, studied this area, okay? And so this is also called the knowledge discovery, okay? So KD, and so KDD is not discovering database because this is really this database researchers want to do some of the machine learning, so the kind of hybrid direction in data mining. Okay, so that's application of machine learning methods to large database, right? So machine learning is really say, hey, I want to support vector machine to be more accurate. I want to, like, say, the neural network to be more accurate. Okay, computer vision, I can recognize objects more with high accuracy. Right? So these are the methods. But data mining is say, hey, I want to use some models on applications. Okay, so these are on data. So the data mining is emphasized on using machine learning on data, the large data. This is becoming popular because the web age, right? So there are so many internet data, social network. Then those researchers found, hey, there are a lot of applications. Also the the DNA, the early days of the biology, bioinformatics, right? So there's so many data coming. So now they are pretty common sense, but by that time, it's quite something for them. But so many data and build those machine models on this. Okay. Yeah, I haven't covered data science, right? So what is data science? Right. Data science is data mining using R or Python. Okay. Unfortunately, that's it. Because there's another definition. Data science is computer science, mathematics, and domain. Okay. The domain means you work on specific data, specific problem. Okay. And this intersection is machine learning, okay? Computer science and statistics, math. Okay. And the second, the most important concept is data science is using Python libraries to do the mining. Okay. And not just the machine learning, by the way. It's data cleansing, all kinds of visualization. But so it's a whole set of analytics. All right. So when is machine learning needed? Right. So so the first is like intrusion detection. Let's say you have some problems, right? Someone is attacking your network, a lot of IP addresses. Even though you are expert, you cannot check every IP address and check their patterns, and because it's so frequent, right? So every second there are so many attacks or potential users valid visits, right? So you really need some tool to help you do that. Right? So it's too expensive, right? So similarly, if you are detecting like a pneumonia from X-rays, like in the COVID-19 like detection, right? So for example, you cannot do that looking at if you, let's say you wanted to test totally from your CT image, right? So then if there's hundreds of thousands of them, right? So you don't want to do that by a doctor, right? So you want to radiologists are limited, right? So it's too expensive for them to go through that. You want to automate it, right? So this is one thing. Second is maybe human expertise does not exist, right? So you learn from the data, and you yourself don't know why from this X you will get Y, right? But once the model sees enough data, they will learn. Right? And let's say you navigate on Mars. This is actually related to reinforcement learning, right? So AlphaGo, right? So the player play with itself again and again and to improve, right? Learn from the failures, right? So it's not because some human is better than them and teach them. Okay? So we will not cover deep reinforcement learning because the time is so limited. If you are interested, you can send me an email. I will recommend some YouTube videos for you. Right? So also there's some experience that human cannot explain. Right? So like visual perception, speech recognition, these are actually where deep learning really comes in. So speech recognition and image detection, and deep GAN, like image generation, right? Synthetic images, and also like natural language processing, right? So question answering, etc. Okay? And oftentimes you don't know how to describe it, right? So let's say if you see an image of cat, why there's a cat there, right? So if I ask you to write a C++ code to do that, even Python code, right? So you don't know how to do it. So these days, the model has become quite powerful. Like, for example, let's say, YouTube, let's go to, yeah, for example, let's look at this example, right? So if you, of course, the model is something like this. I think it's Richardson. I want to stop. Let me mute it. Right? Okay. So we will come back. It's created. Yeah. Now it's back. Okay. Yeah. So what you do is actually give so-called supervision, right? So you let human do annotation. Say, hey, this is the car. You got polygon, and then you feel this. These are Y. Okay. And the image itself is X. Right. So you give this maybe 10,000, 100,000, even more images to to the model, and the model will learn, and then it can use to detect them. Okay, so if you don't learn it, we ask you to write a code from pixels to recognize this is a car, this is also a car. It's gonna be difficult, right? So, and so this is where the deep learning comes in, because we are not coping with a regular table, so we want to first extract features. Okay, there's another feature extraction state. So this is actually a more complicated something like a region proposal, but we will not cover that detailed model. Right? So, but just to get you an idea of the machine learning. So see the pixels and then get the Ys. Okay. Right. So, and human. If you are human, you recognize them and label each of them. Right during your driving, it's gonna be created. Not exactly too expensive. Okay. So, I think I need to do it. Okay, so you don't know how to write the code, but machine learning can learn, right? So, and the problem will change over time. This is more like online learning, right? So, like network routing is an example where, let's say, your traffic changes, right? So, maybe because the time zone is different, at different times, the access patterns change, right? So you want to change your network routing, right? So, I think these days the routing, I think, what's the name of it? Now the routing devices actually can program them, right? So there's, I don't remember so it's start from S, right? So anyway, so there's a way to configure the routing. Okay, so you can configure the routing in a most optimized way, right? So if you use machine learning to learn, hey, this routing is getting congestion, that is better, right? So in network, in internet backbone, for example. Right. And finally, so yeah, you may need a solution for particular cases, right? So for example, for your website recommendation, let's go to YouTube again. Oh, let me see why is it. I think I need to close this. Right, so for example, if you go to YouTube, why he gives you those videos? Maybe I listen to some music and with something else, right? So why he gives you this Trump, or so maybe I watch some movie, right? So these are called recommendations, right? But what I see may be different from what you see, right? So you will see different videos, okay? So these are called recommendations, okay? And so what it says is that, so it needs to know which user really likes what, right? So if, for example, if you click, it becomes a Y for training, okay? And those are the videos, right? So what it does is that, for example, now that you are a new user, right? So this is your profile, right? Within as a features, okay? Dear user. It needs to predict which videos should be recommended to you, okay? Right? But this is called a personalized recommendation. Right? So you cannot pre-compute it for everyone, right? Whenever you log on, it takes this machine learning model and says, hey, these are the videos, show to that person, okay? So this is application domains. Any questions? Yeah, I just feel these are too boring, so we make some real examples because it's a Zoom class. Right? So And so we have some assumptions, by the way. Okay, so firstly, for machine learning, you need the data to learn. Right? So you need to make sure you have big data, abundant data. Okay, data is cheap, knowledge is expensive. Right? So you may say that nowadays we have small data, right? So it's not so important. Right? So no, small data is saying this data is sparse. We need some other way, like transfer learning. There's a well-studied, a lot of data problem. Transfer to small data domain, still learn these things, okay? And there's maybe other open repository, data repository. Right? So you still need those data. Okay, so machine learning always relies on data. It's called data driven. So this is one thing you need to pay attention. The second is that the details of the data generation process is unknown. Okay, so you never know what the function f should be. Right? You want to make the theta flexible enough so that your function f can potentially cover the shape of the mapping from your x to y. Okay, for example. So here we are just talking about supervisor. So, and this is the data generation process. Right? So how the data is generated. So this process is not completely random. Right? So why you see the image, you see those cars. This is not totally random. Right? So you see these people, you know that they are they have a good record. But those people are dangerous for them. Right? So you have the attribute to know this. Right? So it's not totally random, but there's some underlying data generation process. So done by statistical model. That's where the math comes in. Okay. And so what you do is you learning models from the data. Right? So this is actually inverting the data generation path. So what are we talking about here? Right? So you know you have the ground truth, right? That is generating what you see. Okay, this is what you see. Plotting I here. Okay, this is what you see. This is called observations. It's X. Okay, this is your data. So we are not certainly do super. No, actually we don't use that. We repeat. Okay, so probably generating those data. Okay, but you don't know exactly how this is generated. It's too complicated, maybe. So and but what you are doing is this, right? You, based on what you see here, right? You are reversing this process. You are going back to how this data is generated. That's the function. Okay, but pay attention, right? So the actual generation process from the rules that you generate the data is probabilities. Okay, it's a model. But what you are doing is from the data, you want to guess what's a model, right? What's the theta? Okay, so these are the reversing the data generation. The data is generated like this. Okay? Then based on the data you see, you generate a model. Any questions so far? Okay, now let's continue. Right, so again, so this is a very famous, like George Box mentioned. Right? So this is a very famous, I think he's a statistician. So statement. Okay, all models are wrong, but some are useful. So you never know the data generation path from the ground truth. Okay, you are never gonna get the first principle method, right? In the real world, there are so many noise and factors. Right? So, but you can learn from the data, you can learn a p prime that is relatively close to p, and it will give you reasonable predictions in the future. Okay, so we are learning this assumption. Okay, so all models are wrong, but some are useful. Okay, so this is, we are learning the useful model. It doesn't mean that the ground truth is like that. So model is not an exact replica of the generation. Okay, it's not the ground truth. It will never be the ground truth. We'll just close the gap between them. And the model can be either descriptive to get knowledge from data or predictive to make prediction in the future, or both. Okay, so we will see what they mean later. Okay, so descriptive more like, hey, you want to, let's say clustering is one thing, right? So you see the data, you want to see, hey, cluster into, you know, so describe the data. Right? So prediction is really, I don't care about how to understand the data. Just that if you give me X, you give me the right Y, right? You do the F. I don't care how it's generated. Just like the vehicle recognition application we showed in YouTube earlier. You don't care about how the visual system generated. As long as you get me those cards, right, for this frame of image. That's it. Right? The describe is really like a data visualization, right? So you need to help me understand this data, right? So I'm studying the rules and the data. So this is more like this. So sorry, I I think I have trouble with, yeah. I think the annotation doesn't work well with the slides. Yeah, and almost all science is concerned with fitting models to data. So it's inductive method. Even the Newton's rules, that's the principles. Okay, so we are just learning these formulas to describe the rules. So machine learning is to learn these rules. And these rules, why you need machine learning? Because the models are so complicated that oftentimes it's out of sight your intuition and your scope of understanding. And so the role of statistics and CS, right? So in machine learning, right? So if you look at the best researchers in machine learning, okay, so they are not from, they're often from mathematical statistics department. They are not from computer science department, right? So unfortunately, this is the case because, so that's why we also have like data science degree nowadays, right? The CS people, they care about like operating system, like a compiler, right? So the kind of, as a kind of low-level architecture, right? So they spend too much time on that, right? So, and then program, right? Software, J2EE, right? JavaScript page, .NET, PHP, right? And then become software engineer, right? So, and the statistics people, right? Math people, a lot of them later becomes machine learning, okay? But actually, machine learning is a hybrid thing, but some CS people, and those people, if they cannot program, they are in trouble. And really, Python data science is saying, hey, these people, you can either learn, or if you are not rooted in computer science or your computer science pool, you can still use Python libraries. You just call those libraries input output, and you can do your application. Okay, so this is the high-level picture. Okay, so machine learning makes extensive use of statistics in building machine learning models because call it make inference, right? So the mathematics we will teach from a sample operations. From what you see, you build the model. Okay. And the role of computer science is then, now that you know, let's say, what's a mathematical model, you need to implement, right? So you want to build efficient learning anything. Maybe the model is there, but it will take 1,000 years to compute. Then that's the problem, right? So you don't want it, okay? And so there's also performance criteria we care about, right? So in computer science, if you look at all the research, we only care about 3 things, right? So one is, like in machine learning, it's more accurate. Right? So higher like precision, recall, accuracy, format, etc. Okay, more accurate prediction. Right? But the prediction itself can take forever. Right? So we also care about how fast it can run. Right? So this is more in traditional database algorithm. Okay, if you run a SQL query, it runs for 10 days. That's not a good query. Right? So similar query, it runs for just 1 minute. Maybe that's good. Okay, for very large data. And there's also something like these days we have security and privacy, right? So most robust. But again, I have to say most of the security projects I see right now is still based on machine learning. Right? If things get more accurate, then you are in trouble. Right? So you, for example, the people can steal your information or predict your information. Right? And then you want to find a way to tackle that defense. Maybe steal by machine. Okay? So machine learning is now very important. Okay? And also, if you learn machine learning, well, and get familiarized with libraries, you can work with anybody, right? In Ruby, we have all kinds of people, like so medical imaging, like CT, and we also have bioinformatics people, right? So sequence data, and you also have, let's say, the neuroscience people, right? So you can work with all of them, right? So it's like the safest direction, okay? And so examples of tasks. Right, so here are the category of the tasks that in machine learning that we will see. Okay, so the first is association rule. Right, so for example, if you see those videos and you are likely to also watch that videos, and they will recommend. This is called association. Right, and the next is called supervised learning. So supervised learning, what is supervised learning? Right, so if you only see the data, right, so you only see X, that's not supervised learning. If you see X and you also have somebody supervising, which means teach you. This is Y for this X, right? So like you see this image, this is the cat, okay? And that is the cat, okay? And also, let's say you see a record. So this guy is safe, that guy is dangerous. Don't right? So this is supervised. You have Y, you have X, okay? And so the Y can be classification and regression, right? So and it can be hybrid. Okay, so classification and regression. This is called predictive learning. Okay, Let me give you an example of how these days models can make. You may see, let's say, some models are super complicated, but actually down there, they are still, everything is mapping to classification regression. Okay, so if you don't know classification regression, let's say a lot of people, they want to say machine learning, they don't even know how to model the problem to machine learning, then they're in trouble. Let's say, let's go to, let's look at one model called object localization. Okay, so this problem defines something like this. Right? So here's the example. Right? So you want to say, hey, what is in the where is the object in here? Right, this rectangle. Okay? And then what's the object? Maybe here, this is the cat, this is the dog. Okay, how is this achieved? Right, so it doesn't look like intuitively, it doesn't look directly like a classification or regression problem. Right, so but down there, it's actually modeled as such. Okay, let me see. I think there should be an image illustrated. Yeah, here is the image. Okay. But let's just see this. Okay. So what you do is, again, why this is so low resolution? But it's fine. So you have classification or regression, right? So because you know whether this is a cat or dog, right? It's a classification problem. You have class, okay? Cat, dog, other animals, right? And now you also have the bounding box. So bounding box is actually represented by coordinates. X1, Y1, X2, Y2, right? So these are coordinate numbers. That's why you have regression, right? So you want both to be accurate, right? So location is accurate and the object also. So everything is finally modeled as classification or regression in deep learning. If you don't know these concepts, you are in trouble. Okay. So even if complicated, why these works are important? Because they model it into machine learning. Right. Okay, that's why we need to first use this lecture to build a mindset. Okay. And machine learning has gone crazy. Okay. I think it's kind of, so for example, if you look at this researcher, yeah, as types 3 times computer vision, right? So you can see this guy is doing computer vision kind of machine learning stuff, right? So deep learning stuff, right? So the citation since 2015 is like this, right? So this means so many people are citing Cunningham, okay? And if you look at one single paper, let's say the ResNet paper, right? So in just 4 years, right? So there are 54,000 people, right, citing here. That means you have to publish so many papers, right? So that's crazy, okay? So this area is becoming, you know, it's becoming like machine learning is now Word, Excel, UPT, okay? Everyone needs to know it. Or down the road, 10 years later, you find all peers know it. You don't. It's just a tool that you can use for security, for medical research, etc. Right? It's getting a lot of momentum these days because of TensorFlow and Python. Okay? And for unsupervised learning, then you only have X. You don't see Y, right? Like clustering, right? So if you see, let me give you an example. So clustering, I think these days we have the image that's super, right? Let's say you see the data, right? So you want to make sense of them. Right? So you can do, let's say, the Gaussian mixture. Right? You will say, hey, these are generated by 2 different Gaussian. Right? So you can get 2 different components from the data. Maybe these data will be the patient data, and you find the 2 important factors, right? But all you see are the patient data. You don't see why. Okay, and then you can say, hey, there are obviously 2 clusters there, right? And then let's say there are 3 clusters there. And you only have X. There's no supervision. This is called unsupervised. Okay. And reinforced learning. Reinforced learning is more complicated. It's like you need to play with yourself, right? So games, you know, robotics. Right? So you get the feedback from the environment. You don't get the feedback from human. Okay, so and you like AlphaGo play chess with a machine itself and try to beat itself. Right? So then this becomes reinforced learning. Again, this is a very interesting area, but we don't have time to cover that. Okay, let's say Google DeepMind. The whole company is devoted to reinforced learning. So there's also other learning paradigms. Okay, the first is called semi-supervised learning. Right? So what is semi-supervised learning? It means that it's in the middle of supervised and unsupervised. Right? So basically, we are saying that, for example, you have some data X. Okay, some data you also see Y. Okay. Okay. Then you want to do something like, hey, what are their ones, right? So this is called semi-supervised. You want to predict models and you can, so this is because some are supervised, some are unsupervised, right? So this will be useful because, for example, you can still use a, like an unsupervised method to extract some feature from this, right? So it's a richer data information, right? Then you can use this Y to close the gap, right, between the ground truth and the prediction, right? Example is like, say, if you have a social network people, you want to target those people to get advertisement, right? So you know these people are like this product, right? But a lot of other people don't, right? So how can you learn this kind of relationship between these people? How can you say, hey, what are the other people I want to recommend this product to, right? This advertisement. So this becomes semi-supervised. Some you know, some you don't know. Okay. Yeah. So these are just the concepts. Okay. We are not touching detailed model because you need to know some concepts in machine learning that people talk about the terminology all the time. Okay. There's also multitask learning. What is multitask learning? Multitask learning is saying that, okay, so I have two problems, right? So one is to predict, let's say, what are the objects in the image, right? And the second problem may be, hey, are they having trouble? Let's say these two cars are too close or they are crossing the lane, right? So these two problems are both taking the same X, right? But they are for different tasks, okay? If you train them together, there will be some shared feature together that both of them can benefit. Right? So this is called multitasking. You have two different tasks, co-training on your data, okay? And there's also multi-label learning. Multi-label learning is even simpler, right? So let's say you have news, okay, news. And each news can give a label. Let's say this is the sport news, okay? That's a political news, right? So about politics, right? So this is something else, right? So it's technology, right? But again, this becomes a simple classification, right? Multi-label learning is also called multi-class learning. Say, hey, this news, right? It's both about, let's say, technology and sports, okay? So this is, you have multi-labels, right? So it's like tags, you have multiple tags. So this is called a multi-label. It's classification, but you are not just belong to a unique class. You can belong to multiple classes, right? Yeah, for example, the Fitbit, right? So Fitbit is related to sports, it's also technology, right? So yeah, news about that, maybe sports and technology. Yeah, so let's take a look at some examples here. Right? So the first is learning associations. Right? So this is basket analysis, where so this really is starting from the association rule mining, where let's say let's say somebody already buys some product X. Now you want to predict how likely this guy will also buy product Y. Right? So actually, this is what's happening in supermarket. Like why? So you know, people like why they put things close together. Right? So they're actually based on social rules, because they know everyone buying those transactions. Right? So they can see them. Right? So let's say, for example, 70% of the customers who buy beer also buy chips. Right? So then maybe they will put like the beers right opposite to the chips, you know, counter where you can get them together. That's not far. Okay. So in machine learning, if you want to differentiate different customers, because maybe you like a beer and a chip, right? That guy may not like beer and a chip, right? They like a juice and a chip. Right? So for different people, they have different attributes, like D, okay? Gender, age, and other user profile you can put. Then this becomes a machine learning. Okay. Without this is actually a data mining model called association rules from frequent pattern mining. Okay, frequent IC. But here, if you want to add some user features, then this becomes more complicated. Machine learning, because for different user, you may have different preferences. Yeah. So second example is credit scoring. Right. So this is a classification problem. Right? So we put classification. So you want to differentiate between low risk and high risk customers according to the attribute X1, X2. Right? X1 is income, right? So this is like every month you are earning enough, then you are safe. Okay, you will pay back the money. Another is even if you are poor, you are laid off, but your dad is rich, let's say multi-million dollars. Right? So then you have a lot of savings. Yeah, it's safe to borrow money. Right? So okay, so these are examples of the future. Okay, so. Discriminant classification rule can be defined like this. Right? So if, let's say, your income is higher than a certain value, and your savings, you also have certain savings, right? You save maybe 100K in the bank, and also your monthly salary is more than $5,000 per month, then maybe yeah, you are safe one. Right? So if you are here, you are low risk. Okay, otherwise you are high risk. So this is you can see this already a optimization problem. Right? So you have X1, you have X2, and you have a Y. Y is a plus or minus. Here, Y is a classification, so you only have two classes: low risk or high risk. But there are other applications like face recognition, right? So whether see your face, that's a valid user or not, right? So or who the user is, right? So and a lot of them. Okay, so I will not go through all. Okay, the raining or not, smart model for the email, okay, smart detector. And so regression. Another example is here for the regression. You can predict the price of the used car, right? So let's say X is the attributes of the car, Y is the price. Let's say you have the car, you see how many miles has been used, right? The previous driver has driven how many miles. It's more, of course, it's cheaper, right? Because the car is good. Okay. And in the meanwhile, you also want to know how good the car is, right? So what's the price when the guy buys the car? So both are important. Right? So model as a regression function. Okay. So here regression function. Here this is a linear function, right? So theta is ax plus b. Okay. Because so a line is ax plus b. Right? So if it's just a line, then you have theta to be a and b. Here is theta. But you have many different lines, right? Which line is the best? Okay. So this line is the best according to this data observation. Okay. So yeah, so let's say this guy see these are the mileage that this person drives and then sell this price. This is the mileage and sales. If you see enough, you can fit a model, linear model. Right? Okay, so this theta. Okay, and then you can predict Y. Next time you see a new car, let's say you see a mileage is somewhere here, and you can see, hey, this should be this price. Okay, so this is a regression model because Y is a price. It's not a class rate. If you have any question, just stop me and ask anytime. Okay. Again, the first lecture is to build a mindset for you to understand machine learning better. Okay. There are also regression problems everywhere. Right? So like the box we talked about for localizing the object is a regression. Right? So also if you have the robotics, how much if you move the arms, that's all regression. Right? What's the movie rating? Right? I recommend you a new movie according to what you rated it for the old movies. Whether you like it or not, that's all this regression. Okay? And I see there was an application where you can get a photo and it predicts the age. So this is again regression. Age is let me see. Oh, unfortunately, I used the I cannot use Zooms. So let me use a pen. Okay, so supervised learning. So basically, it's classification and regression because you will see why. If it's continuous, it's regression. If it's discrete labels, it's classification. Okay. So the purpose of learning this is because firstly you see X and Y. Right. Next time you get a new X, you want to predict this Y. So this is really for predicting the future cases. This is predictive model. Okay. With the output for future input using the rule learning. Okay. And then you also have, let's say, knowledge extraction. Right? So maybe you learn the decision tree we see before. You also see X and Y. But then you only need a tree because this tree is easy to understand. You can interpret. Right? So if this guy of this age and high risk, then he should go to this doctor, check this and that. Right? So this is knowledge extraction. Okay, help you to learn rules to understand. But unfortunately, as far as I know, only the decision tree is interpreted. All other models are kind of not interpreted. Okay, of course, visualization also it's trying to make uninterpreted models to be more interpreted. It's still not perfect. Okay, or clustering. Okay? And compression. Right? So compression is if you learn the rule, right, it's gonna be simpler, right? Then you just remember the rule. You don't need to remember all the points. Example of this. What I can. Example of this is this example, right? If you remember all those red dots, there could be a million of them, right? You can never save them, okay? But if you learn this line, it's just ax plus b, and you can just save two numbers, a and a b. So you know the rule, okay? So this is why we say it's compression. And finally, outlier detection, right? So this is the fraud detection for credit card, for example. If you see most people are, let's say, most people, they are X1, X2, X3, they are featured here, but this guy somehow is here. Let's say they must do something very weird. Let's say visiting some IP address too much, you know. So then this is a kind of fraud or, you know, outlier. Then we can look into. Right? So sometimes we want to detect those outliers, those potentially noise, rather than those part of regular cases. Okay. And the next is unsupervised learning. So unsupervised learning is you just see X, you don't have Y. Okay. So you are learning what normally happens and what's interesting about it. Okay? You don't see you don't see Y. You are trying to interpret X into maybe finally you will get what Y you want, but initially you don't have to. Okay? And so this is actually typical of human animal learning, right? So when you learn initially as a baby, no one teach you, hey, this is a car, that is a bus, right? So you quickly grasp all of them without the supervision. Okay, so no output is given, right? So you just make sense of that, right? Like clustering. Okay, but unfortunately, this is much less well defined than supervised learning, right? You can imagine that, right? So clustering, maybe that cluster makes sense, but you can interpret different ways, right? But if you look at the X and the Y, it's basically I want to learn that Y, right? So these are the cars. Okay? So for supervised learning, you have reasonable metrics, but you don't have obvious error measures. You will just have some user-defined error measures saying, hey, if these different cluster points are separated apart, then it's good, right? So you define some metrics to define that. But there's no obvious error measure. Okay? You don't know whether it's wrong or not. And then the next is density estimation, but we are almost up to time, and there are still 84 students with it. So yeah, so we will continue next time from here. Okay, so next Monday, and do go through those Jupyter node files and the previous slide we covered. Okay, so there's a lot of things to go through for this week, and I will stop here, and I will stay online for maybe 3 minutes until 7:30. If you have any questions, feel free to ask me. Okay. And you can immediately, yeah.
Professor, I have a quick questions.
Okay.
Actually, how well the machine learning models are performing in the real life industries? Does them perform? Are they performing well?
Oh, okay. Let me tell you the truth. Okay. So machine learning models are just saying, hey, I want a Y, and you are predicting Y hat, right? And I see the X, which is the plane. Okay, right. And then what you do is mathematical model try to close the gap between their difference. Okay, you want to move to here. Okay, this will be what we teach. But the question whether they are close enough. Let's say if you do self-driving car, right? If some mistakes will cause accidents, right? Then it's worrying, right? So how large you can close the gap? That's application dependent, right? So for maybe for recommendation, for the object detection, they are working well. So, but for some certain tasks, they are not working well. It depends on your data quality, X and Y, and how difficult the problem is, right? And so all we do is make sure it's rather good points, right? But whether the gap, the error is small enough, it depends on the application. And the killer application in machine learning are those that the best, the lowest error point, the error is tolerable, so you can use it. Let's say if I recommend the videos, right? So if some videos are wrong, it's fine. If I have several other videos that are good, I will click them, and then they will play the advertisement at the front, and they make money. That's what you do, right? So these applications are the killer applications. Yeah, self-driving car is a effort that people are trying to do, but this is dangerous because it's life critical, right? If there's any lawsuits, the company is in trouble, right? So yeah, so the recommendation is yeah.
Okay, I got it, sir. Apart from this, how well the machine learning models perform on the data that I haven't seen actually. Let's say the data which is present from, let's say you were talking about the insurance, right? Insurance example. Let's say the data is from 40 years age to 60 years age. Will the model, let's say we have built a best model for the given data, will it perform? Will the predictions will be applicable to the data which the person age is above 60?
Oh, let me tell you the truth. So machine learning models are never 100% accurate. Okay, so if you predict in the most people that will not pay back the money are detected, maybe 2 or 3 are wrong. That's fine. So this is the difference from algorithm or database, or if you do a SQL query, right? So you get all the person with more than that salary. If you get all of them, you are correct. Otherwise, you have error. But machine learning is always less than 100%. Okay.
Mhm.
There will be some small error just to see whether you can tolerate that. And that's why in the application, you see whether this 1% error or 5% error is okay with you or not. So most of the time, it's more like a recommendation to human. If you let it make decisions, it's gonna be a little bit difficult, but the people are trying to do that.
I have a question.
Yeah.
You said the machine learning is it's not exact. Then it's all about the optimization.
Yeah, most of them are. No, not absolutely. Let's say decision tree, not right. So, and if you look at k-means, the k nearest neighbor, right? So you see what's the nearest neighbor of yours, and what's the label, and your label is likely to be similar. There are some algorithm ones. So this course will focus on optimization, because data mining will cover the other models, right? You have another course.
Okay.
Yeah, and we are trying to do something differently from deep learning and data mining, because we also have these 2 courses. Right? So we don't want to overlap a lot of the models. Yeah, any other questions? If not, I will stop share. Yeah, so if not, I think that's the end of today. Thank you.
Thank you so much.
Have a good evening. Oh, I see some new messages. Okay, yeah, you're welcome.